The lesson outcome for this video is I can use slope to describe lines. On the coordinate plane, you see a red line. We are going to talk today about how to describe lines based on their slope. Now, slope is a word that is used to determine or used to describe the amount of steepness that a line has. If you think about slope in reference to skiing, downhill skiing, for example, or other activities where there's a hill involved, you can talk about how something is very, very steep, or when something is not steep, it would be more like this. So, and obviously even less steep would be a horizontal line because it has no steepness. Now, the line on the coordinate plane, first of all, notice it is an increasing line or function. It is increasing because as the x values here, as the x values get larger, the y values get larger as well, and that defines this as an increasing slope. The line is increasing. When a line is increasing, the slope is positive. Okay, the slope is positive if the graph is increasing. In a minute we'll talk about when a graph is decreasing. So the slope is positive, and what slope really is, we use a ratio to determine slope, and that is going to be the change in the y values over the change in the x values. So if we find a spot somewhere on this line that goes through, what's typically easier is when it goes through two whole numbers. So let's say right about here, if we think about that y-intercept right there, and if we find another point somewhere on this line that goes through what looks like two whole numbers, so let's say right here, we can find the slope by finding the change in the y values and a change in the x values to get from this point up to this point. So the change in the y values has to go in the numerator of this fraction for slope. It has to go in the numerator, because another phrase that you probably have heard before is rise over run. So how much does it rise and how much do you then run over? So from here, we rise 2 units, and then from there, we run 1, 2, 3 units to get to the other point. So our rise for this line was 2, and our run was 3. So the slope of this line is 2/3. Now notice, you have to remember to pay attention to if you're rising up or if you're rising down. So are you going positive or negative? Again, looking back at this, from here we're going up and right. Up is positive, if you think about this as being, positive this direction, and this direction is also positive. Down is negative and left is negative. So from this point, we are going up, which is positive, and right, which is positive. And that means we have a positive 2 and a positive 3, which is a positive 2/3 slope. Okay, so if you take a look at this graph now, you'll notice that this line is decreasing. It's decreasing. It's going downhill, again, from left to right. If we're moving from left to right. So as the x values get larger, as the x values go this direction further and further, and we notice that our y values get smaller and smaller. That shows that it is decreasing. Okay? So it's a decreasing graph, and when the line is decreasing, what does that tell us about our slope? Well, it tells us that we're going to have a negative slope. Negative slope. Okay, and again, if we think about the idea of rise over run, or in other words, a change in the y values over a change in the x values, we will find our slope. So if we think about finding a point on this line anywhere you want, again, I would suggest you look for where it looks like whole numbers are are where they're intersecting some of the grid lines. So let's take a look here. Maybe this point right here. Okay, and then another point somewhere again that looks like it's going through two whole numbers or two, whole numbers, so maybe right in here. Okay, so it looks like we're going to approximate our slope here with our rise and run. We are going from this point right here to that point, or you could go from this point to this point. It actually does not matter which direction you go, and I'll show you how. So let's say I was starting here. I've risen 1, 2 downward. Again, this is negative, this is positive, this is positive, this is negative. So I've gone from here 1, 2 units down, so it's -2, -2, and then from there I've gone 1 to the right. 1 to the right is 1 positive, +1, which means this will be like this. Our slope here is -2 over 1, which does simplify into simply -2 if you wanted to do that. So our slope in this line, for this line, is -2. Notice it's negative, which is good, it's going downhill, and the slope is 2. Now what if I had gone the other direction? What if I had started at this point and gone up to this point and counted my rise and run? Well, if I go up 1, 2, that's 2 in the positive direction, so I could also write 2 in the positive direction, and then from there I have to go 1 left. And if I'm going from here to here 1 left, I'm going negative. So that would be -1. Notice that 2 over -1 is also -2 for a slope. So same answer for our slope, doesn't matter which direction you travel from one point to the next. Okay, so what about this line? This line, the green one there, you can see looks flat. Okay, so when it looks flat, it's not going uphill, it's not going downhill. So to think about our rise over run, we can still do the same thing, stay consistent. So our rise, let's pick 2 points, all right? So from, let's say, this point right here, I just picked a point, doesn't matter where, and I'm picking another point right here. So if we count our rise and our run from here to here. So how much am I rising? I'm not going up or down at all to get to this point. So that's 0 is my rise, 0. And then my run, again, from here, I've moved up or down 0, and now I'm running 1, 2, 3, 4, 5. So my run is 5 to the right, which is +5. Now what is 0 divided by 5? Well, 0. 0 divided by 5 can be computed. If I have $0 and I divide those $0 by 5 people, everybody gets 0. So this is what we call a 0 slope. And horizontal lines always have a 0 slope. How about if we had this line? Right, it doesn't matter where, right here. Okay, so if we have this line, and again we pick a couple points on there to do our slope, here's one and here's another one, doesn't matter where they are, there they are. Our rise from this point right here to the other is 1, 2, 3, 4. So my rise is 4. And then my run, again I went rows 4, and my run, left or right, I didn't move any, so that's 0. Now this you can't compute. Dividing by 0 is not something we can do in mathematics. Again, think about if you have $4, you can't divide that up by 0 people. That doesn't exist because you own the $4 already. So you're dividing it up by 1 person already. So 4 divided by 0 just cannot be computed, it cannot be done. And therefore what we call that, instead of an equal sign, we probably should just say, this is what we call undefined slope. Undefined slope. So a vertical line will always have an undefined slope. Okay, calculate the slope of these 2 lines and then check back to see how you did. I decided to use a couple of points on this line that I thought look like they're going right through the whole numbers at that point and at this point here. Those are the 2 points I used. And since that was the case, I counted my slope as, from this point right here, down 1 and right 1, 2, 3, 4, 5. So down 1 and right 5 is a negative 1/5 slope. Your answer should have been negative because the line is decreasing. The second example, the line is increasing, so your slope should be positive. The points I chose on this graph, let's see, maybe this point right here and this point right here. I think those are the two that look mostly right on those intersections. So again, we'll count from one line or one point to the other. The rise is 1, 2, 3, 4, 5, 6. So rise is 6, and the run is 1, 2, 3, 4, 5, 6, 7. So rise is 6, run is 7, the slope is 6/7.